In this lesson, we are going to look at analyzing puzzles and/or games. So we're going to look and see if there's some strategies to winning a game or solving a puzzle. Frank and Tara are playing darts using the given rules. Their scores are shown in the table below. To win, Frank must reduce his score to 0 and have his last counting dart be a double. So here's the rules. Each player's score starts at 501. The goal is to reduce your score to 0. You alternate turns. You get 3 darts per turn. So what strategies for play would give Frank a winning turn? So if we look, Frank has 36 points to get to 0. He gets 3 darts, and in keeping in mind his last dart thrown, doesn't mean he has to use all 3, but his last counting dart must be a double. Now just to make sure you understand darts, the center is obviously your bullseye. That's 50 points. The inner bowl also counts as a double. The dart in the outer bowl scores 25 points. This ring here are your doubles, and they're doubles of whatever score is matching. This one here, or sorry, that was triples. This one here on the outer end is doubles. So what we have is he has 36. First of all, in one throw, is there any way he can score a double and win? So you have to think about what is 36 divided by 2? It's 18. Is 18 one of the scoring points on the ring? Yes, it is. So if he hit a double 18 on his first throw, he would win. So that's one strategy. Now let's say he aims for that double 18, but he misses and scores just a single 18. So he needs 36. He scored a single 18. So that means he's got 18 left. So he has to score a double, so half of 18 is 9. Is 9 one of the counting values on the board? Yes, it is. So he could then try to do a double 9 with his second shot. And if he did, he would win. Let's say he goes for that double 9 and he misses and he just gets a single 9. So now he's got 27 points. He needs 9 more. Can we score a double to get 9 on one shot? And the answer is no. Half of 9 is 4.5. That's not an option on the ring. So therefore, if he misses and gets a single 18 and then a single 9, he cannot win on this particular turn. Nadine and Alice are playing a toothpick game. They place a pile of 20 toothpicks on a desk and alternate turns. On each turn, the player can choose to take 1 or 2 toothpicks from the pile. The player to remove the last toothpick is the winner. Nadine and Alice flip a coin to determine the starting player. Is there a strategy Alice can use to ensure that she wins the game? So you need to think about this one. What Alice has thought about is she was working backwards. In order to win the game, she needs to make sure that there are 1 or 2 left after Nadine's last turn, because then she gets to pick up the winning amount. Now, in order for there to be 1 or 2 left after Nadine's last turn, she has to make sure she leaves 3 for Nadine. Because if she leaves 3, then Nadine picks 1, Alice can pick 2. If Nadine picks 2, Alice can pick 1. So she has to make sure she leaves 3. Then she starts thinking about on her second last turn, how many would she have to make sure so that there would be 3 next. And she's thinking she has to leave 6. Because now if Nadine picks 1, Alice will pick 2. So therefore there would be 3 left. If Nadine picks 2, Alice will only pick 1, and that will allow 3 to be left. So then she continues this path. So now she's thinking, if she leaves 9 on the turn before, would this work? Yes. It's now if Nadine picks 1, again, she can pick 2, so that would be 3, leaving 6. If Nadine picks 2, she could pick 1. That would be a total of 3, leaving 6. So continuing this, multiples of 3, she'd want to leave 12, she'd want to leave 15, and she'd want to leave 18. Now they start with 20. So in order for her to win, she needs to hopefully go first, and she needs to take 2 toothpicks. That makes sure she's always leaving a multiple of 3. If Nadine goes first and takes 2, then Alice has to hope Nadine doesn't know the strategy and somewhere along the way can make sure she leaves a multiple of 3. If Nadine only took 1, she could take 1, and then she would be in her multiples of 3. But if Nadine goes first and knows the strategy and takes 2, then there's no way for Alice to win. So what Alice has realized is she always wants to leave a multiple of 3 for Nadine, and therefore she would be guaranteed to pick up the last toothpick. Both inductive reasoning and deductive reasoning are useful for determining a strategy to solve a puzzle or win a game. Inductive reasoning is useful when analyzing games and puzzles that require recognizing patterns or creating a particular order. Deductive reasoning is useful when analyzing games and puzzles that require inquiry and discovery to complete.